Alright, so this is chemical sentences, aka chemical reactions. So if you will put this sheet in front of you, I will walk you through this front page and then a couple of examples from each of the following sections. So it starts off by saying, just like in language, you can put words together to convey a thought. You can put together chemical names to convey an event. So just like English sentences follow the pattern of a subject followed by a predicate, chemical sentences follow the pattern of reactants followed by products. So what we're going to be doing is stringing together element or compound names in this format with reactants on the left, products on the right, in order to convey an event. We have 5 different types of chemical sentences that are summarized on the front page of the sheet that you should be looking at. The first one is called a synthesis reaction. A synthesis reaction is 2 elements being added together, reacting together to form a single compound. A compound, if you remember, is 2 or more atoms stuck together via chemical reaction. An element is anything that you find on the periodic table, a single element. So this is 2 single things combining to make one. You're going to be using the charges of whatever elements you're talking about over here on the left in order to create the products on the right. Your first example is barium plus sulfur. So these are the elements on the periodic table. And as you know, barium has a +2 charge. Sulfur has a -2 charge. So this compound does not need any subscripts. Your second, let's make that a little bit bigger so you can see it even better. Your second type of reaction here is called decomposition, and it is just what it sounds like. Something decomposes or decay. So we have one thing, one compound breaking down into 2 smaller pieces. These 2 smaller pieces will usually be elements, but not always. In this example here, we have water breaking down into his components of hydrogen and oxygen. If you remember in a previous section, we talked about a mnemonic called Brinkelhoff: bromine, iodide, nitrogen, chlorine, hydrogen, oxygen, and fluorine. And these are the 7 elements that will never be found alone. So when you see them by themselves, as they would be in this example, they're not part of a compound, they're not attached to anything else, so you need to put a little subscript of a 2 behind them. Our third type of sentence is called a single replacement reaction. See if I can fit it in here. A single replacement reaction, excuse me while I reach for something. A single replacement reaction involves a compound reacting with an element to make a new compound and a new element. So, 1 compound, 1 element on the left, 1 compound, 1 element on the right. Remember that when you're making this compound on the other side, that you can never put a positive with a positive. You always have to put a positive with a negative. That will make sense when I show you some more examples. Always double check all of the charges on both products and reactants. Make sure they equal 0. So, for example, this guy here. We know that barium has a +2 charge, sulfur has a 2-. Oxygen, never by himself. So on this side, I have again a +2 and a -2. Notice that my oxygen and my sulfur have switched places. I started off with a compound and an element. Over here, I now have a new compound and a different element. That's what makes a single replacement reaction. One thing has moved. Our fourth type is called a double replacement, and this is where everything moves. Our positive is going to go with a new negative, and again, always double check all of your charges. For example, in this example here, sodium has a +1, chlorine has a -1, magnesium has a +2, oxygen has a -2. On the other side, magnesium has a +2, chloride has a -1. So my chloride started off with my sodium. Now it's going to switch and be with the magnesium. But chloride has a -1 charge. Magnesium has a +2. I need a subscript of a 2 to counteract that +2. Sodium has a +1. Oxide has a -2. I need 2 sodiums to counteract that oxygen. So notice how the subscripts had to be added on the right to make sure that all the charges balanced. And I want you to make a big note. This is not written, so you need to make sure to write this in. The only time a subscript may cross the arrow, so this arrow here, the only time that a subscript may cross the arrow is when it is part of a poly. So, only time a subscript may cross the arrow is when it is part of a poly. So if a subscript cannot be found on your ion sheet, it may not cross from one side of the arrow to another. Feel free to pause the video if you need a moment to write that down. Our fifth type of reaction is called a combustion reaction. Combustion reactions always involve organics, and organics are composed of carbon and hydrogen, possibly oxygen and nitrogen, and it will also involve oxygen gas. This is oxygen in its natural state. Found out in the wild, O is never by itself, so it gets that 2. Remember your Brinkelhoff. The products, put a big star by this one, the products are always water vapor, H2O, and carbon dioxide. Always, always, always. So anytime you have something involving CH and our oxygen gas, the products will always be carbon dioxide and water. No charges, no muss, no fuss. That's it. So that is a brief summary of all 5 types of reactions. In the next video, we will begin doing examples from the 2nd page. So in the next video, please turn the page and let's start with number 1.